We've talked about estimating the area under the curve using rectangles. And we've talked about getting exact values with the definite integral. But we're going to talk about today a couple more estimation um, ways to handle the area under a curve. We use these a lot of times for data analysis when we don't have a specific curve more than anything else. But I'm going to give you a programming class to do them just like we did with the RAM, but today for the video I'm just going to show you how to do it by hand because you do need to know how to do that. Now, if you have a curve, let's say we have a curve like this. If we use rectangles, you notice that we have a lot of space where it's either leaving some out or we have too much. It doesn't really go along the curve. So if we find a better shape to do this, we can get a more accurate answer. So we use trapezoids sometimes to find that area. Now, to remember a little geometry here. You see that the trapezoid fits it better, if I could draw a straight line. But you remember that the area of a trapezoid is 1/2 the first base plus the second base times the height. Well, let's get it black so we can see it easier. If we pull one of these trapezoids down here, you see that you've got this base 1 here is going to be your y value. We'll call the first one y0 because it's from the x-axis up to the curve, right? And your second base goes from the x-axis up to the curve to the next y value at x1. If this, we'll call this x0 and this one x1. So we've got our B1 is y0 and our B2 is y1 based on the curve. And then our height is this delta x. So we've got our y values and our delta x. So the key thing to remember about this is the fact that your trapezoid is kind of turned on its side. Now, in your book, you have the formula written out on page 290. They derive it all for you. But I'm going to just kind of give it to you. This delta x, if we're going along an interval, the whole interval is from A to B, the x values, then this delta x is going to be B minus A over n, where n is the number of trapezoids we have, just like we did with the rectangles. So we can rewrite this formula as 1/2 times the y0 plus the y1 times B minus A over n. So that's for one trapezoid. If we want to add them all up, you'll see that for this trapezoid, our B2 is y1, but for the next trapezoid, our B1 is going to be y1. And then when we go to the next trapezoid, we'll use this as our B2 for this one, and we'll use this as our B1 for this trapezoid. So they'll overlap. So what you end up with is a formula that looks like this. We're just going to call that H. This is your H here, remember? H over 2 times, now that first one we don't repeat, but the second one we do, and the third one, and so on and so forth. And then the last one we don't repeat either. So this is adding up all of the bases as we need it, and then this gives you the 1/2 times this H part here. So this is your trapezoidal formula. You do need to know this because there may be questions on the exam where they ask you to do this without a calculator. But as I said, I am going to give you a formula to go in your program, to go in your calculator so that you can do this on your calculator. You can, of course, just figure out the area of each trapezoid and add them all up. That works too. So let's try an example here. Let's say we want to estimate the area under the curve from 1 to 2 of the curve 1 over x using the trapezoidal rule with n equals 5. All right, so the first thing we want to find is a picture so we kind of know what we're doing here. So 1 over x looks like this. And if we're going from 1 to 2, then we're looking for this area in here. And we know that this is at 1 and this is at 1/2. So this is the area we're looking for. And of course we could just integrate this, but we want to practice with the trapezoidal rule. So we have our n equals 5, which means that our h, remember we take b minus a over n, our h is 1/5. So that means that each of our trapezoids, if we're using 5 trapezoids, is 1/5 of a unit wide. So what we do is we list out our x naught. We start with a, and then our next one is a plus our h. So we've got 1.2, or 1 1/5, and we just keep going until we get to our b. Now, why do we need these? Well, the main reason you need those is because we need the y values. So the easiest way to do it is to list out your x values, and then you can have your y values. So our function is this here, 1 over x. So our y values, we take these x values and plug it in. So 1 over 1 is 1. 1 over 1.2 is 5/6. 1 over 1.4 is 5/7. 1 over 1.6 is 5/8. 1 over 1.8 is 5/9. And 1 over 2 is 1/2, of course. So if you do this, of course, you know this is 12/10. 1 over means take the reciprocal. We took the reciprocal and simplified it. So hopefully you know how to do that. That's about 6th grade at best. So make sure you've got that. I know we have some trouble with decimals and fractions, so make sure you get that. So to find the area using the trapezoidal rule, we've got all our information now. We take our h over 2 times our y naught plus 2 times y1 plus 2 times y2 plus 2 times y3 plus 2 times y4 plus y5. So everything's times 2 except the first one and the last one. And if you multiply that all out and add it all up, you end up with 0.6956. So this is how you use the trapezoidal rule formula. All we did was find the area of each of these trapezoids. So we had one trapezoid here, and the area of that trapezoid was 1/2 times b1, which is y naught, the 1 over 1, plus b2, which was the 1 1/5, 1 over 1 1/5, so that's the 5/6, times the height, which is the 1/5 here. So this red trapezoid is just this area here. And then we went along and added them all up, and you end up with this formula. And you add them all up. Make sure you understand where the formula comes from, how we get it. Read that on page, I think it's it's 289, 290, something like that, where they derive it for you and give you the trapezoidal rule. One thing to point out about the trapezoidal rule is that you can also calculate the trapezoidal rule by taking the left-hand rectangles plus the right-hand rectangles and averaging them. Okay, if you have the same number of n values, then it ends up being the same thing. So, just for your information. But we're going to use a program for this in class, but make sure you've read this section about the trapezoidal rule, and the other method, the Simpsons method, we'll do in a separate video. So look at this, read a few examples in your book, and make sure you understand the trapezoidal rule.